Hello Internet, and welcome to this quick video on congruency in triangles, specifically some example questions I'm going over. If you haven't already seen my video on proving congruency in triangles, I would recommend watching that before this, otherwise this won't make too much sense. Moving on today, if you'd like to go through the questions yourself beforehand and then just check the answers, please feel free, otherwise just follow along with me. So first of all, we are told that ABCD is a parallelogram, and we are asked to prove that triangles ABD, which is this triangle here, and BCD, which is the triangle left over, are congruent, meaning they are just exactly the same. The first step to doing this is proving that the line BD is shared. If this line is shared, it means it must be the same on both triangles. Next up, we can say that opposite sides of a parallelogram are the same. Therefore, line BC is exactly equal to line AD. And finally, we can say that BA equals CD for the same reason. And from here, we can say the triangles are congruent by SSS, or side, side, side. Again, if you watch my video on proving congruency in triangles, it goes over the 4 ways of proving congruency. Here's an example of another question. We're told that in the diagram, the lines CE and DF intersect at G. CD and FE are parallel, and CD equals FE. Therefore, proving that the triangles CDG and EFG are congruent. So the first step we're going to take is by proving that angle FGE and DGC are the same, and we're going to do this as those two angles there are vertically opposite, therefore they must be identical. Next up, we can say that alternate angles are the same, therefore CDG and angle EFG are also the same, and alternate angles are the ones which create a Z sort of shape. And finally, the question actually tells us that line CD equals FE, therefore proving that those two lines from either triangle are the same. And from here, we can say that the triangles are therefore congruent by ASA, which is angle, side, angle. And our final question here is telling us that DEF is an equilateral triangle, and we are told that G lies on EF. DG is perpendicular to FE, and we are then asked to prove that DFG is congruent to DEG. And DFG is the triangle on the left, whereas DEG is the triangle on the right. You can actually prove this in all 4 different ways, but I'm only going to be going over one example in this video. However, if you did prove it in another way, that is certainly possible. So the way I'm going to go is I'm going to first say that line DG is shared, therefore it must be the same. I can then also say that angle DFG and angle DEG, as you can see labelled, are both the same as well, as all of the angles in an equilateral triangle must be the same. And as you can see, those two angles are both from the original equilateral triangle, so both must be 60 degrees. You don't have to write any numbers or anything because you're just proving that they are the same. You're not proving any values. And finally, I can say that angle FDE is split exactly in half by the line DG, therefore the angles either side of that angle must be the same. Once again, that would be 60 degrees as it's part of an equilateral triangle. Splitting it exactly in half will leave 2 angles of 30 degrees and 30 degrees, therefore they must be the same. Once again, we've used ASA, or angle side angle, to prove these triangles congruent.